Hey, let's write two-step equations. Okay, here's where we take the English language and turn it into a math sentence or a math equation, and kind of go from the reverse to. More importantly is being able to read a real-world problem and convert that to an equation. That's where the math really pays off. Like, you're never going to run into this in your life. You're going to be like, hey, you know what I need to figure out tonight is 15 equals 3 more than 6 times a number. That doesn't come up on your taxes. What does come up though in your life is stuff that has an initial fee and then a cost per month. And if you're doing any sort of budgeting with your money, that matters to you. You want to know how much you're going to end up spending. Purchasing a phone is like that. Buying a car is like that. Buying a house is like that. A lot of the things that you do in your life will require that. This is just the foundation of that type of thinking. So let's just go to these two problems here. I got 15 equals 3 more than 6 times the number. Now, some people like to do a lot of drawing, a lot of writing, a lot of stuff all over this. Let's just walk through it the way that it says is. So it says 15 equals, so I'm just going to write 15 equals. All right, so I'm here now. 3 more than 6 times a number. Remember that a number bit? That a number is something we don't know. What do we use to represent an unknown value, a variable? So let's do 6 and y. 6 times y. 6 times a number. That's pretty simple. All right, let's look at this one then. 7 less than, less than 1/4 of a number is -3. Now, like, you've done this 3 years in a row now. This is the crusher right here, less than. It's just a brutal one where maybe we overstress it so that you overthink it. Less than. So if I said you had 3 less than $20 in your pocket, would you have 3 minus 20, which is -17, or would you have 20 minus 3, which is 17? You're right, it's 20 minus 3. So when we say 3 or 7 less than 1/4 of a number, 7 less than means I've got -7. Something has been taken away, something has had 7 taken away from it. What has been taken away from it is 1/4 of a number. So I know that's an x. Now I need 1/4 of that unknown. 1/4. 7 less than 1/4 of a number, which means I have a number, and then take away 7 from it to get 7 less. And then our classic is here, is equals to, and it's equal to -3. -3. This is the kicker, right? That less than is the one where math teachers deliberately try to get you. Let's do it in the reverse then. So I have an example. Can we write the words from an equation? That said equation is going to be 3y minus 8 equals -23. And my goal here is let's actually use less than. Okay? Let's use less than in this example. I have 3y minus 8 equals -23. So if I were to write this out, what I would say is, I would start here and say 8 less than, right? 8 less than, so I'm going to take 8 away from something, it's this. So what do I have here? What's the coefficient? It's 3. 8 less than 3 times a number, which is that y right there. And then here's our big old is -20. Now I remember learning this when I was like in 4th grade maybe. How to write out these numbers, and some of them are hyphenated and some of them are not hyphenated. I'm going to put the hyphen because it looks like I know, but I don't know. It could be hyphenated, it could not be hyphenated. I have no clue, right? So that's just the inverse of this, how this looks using with the less than here, just to specifically target that problem area that we have. All right, let's do one more here, and it could be a word problem, and deciphering a word problem is critical. Here is that promised word problem. Mr. Romanovich wants the new streaming service Encompass. So Encompass is great. It's one device that takes all my streaming services and puts them together, and then I don't have to switch back and forth having to load and reload different services because that takes so much time and it's frustrating. It cost me $150 to buy the device, you know. So it's $150 for the device. Then it cost me $15 a month to use it. That's my subscription rate, right? So I've spent $290 so far on the service. How much have I spent? How long have I had it? How many months have I had it? All right, so let's look back in the problem and see what we've got here. Okay, how many times am I going to buy the device? One time. So if I buy the device once, that's my constant. Now I'm going to kind of write this in the way that I like my two-step equations with my variable out front. It's going to cost me this much money. Then I've spent $290 so far. 290, that's not right. No, 240. I've spent $240 so far, so that's how much I've spent. And I spent $15 per month. Now we don't know how many months, right? That's our unknown. So that's then 15x. All right, so we're solving a two-step equation here. Subtract 150, subtract 150. Now I have 15x equals 90. Divide both sides by 15. I'm going to bring that up here so we can see it. 15x equals 90. Divide by 15, divide by 15. And we get x equals, do some side math, 15 times 6 is 33. 6. X is 6. But is x 6? Is that the answer? X is 6? No, the answer is not x is 6. The answer is that I've had it, let's answer that question right there, that I've had it 6 months. Here's where that writing two-step equations matters, right? We can practice it with those algebraic sentences, that's great, but using a real-world example and then drawing that equation out of that, that's the thing we need to be able to do. Okay, good luck, guys.